Hi there. In this video, I'm going to show you how to model this carport in FreeCAD. Through this example, you'll see how to quickly create a fully parametric assembly 3D model without using the assembly workbench. We'll be using a direct assembly method based on a master sketch. And as a bonus, I'll share a macro that lets you export a parts list of all components with their quantities into a spreadsheet. This tutorial is aimed at FreeCAD beginners who want to level up their 3D modeling skills. You can download the FreeCAD file of the carport, along with all the sketches we'll be creating, completely for free from my Ko-fi page. If you'd like to support the channel, feel free to leave a donation. It really helps keep things going. Thanks in advance. The first time you fire up FreeCAD, you'll land on this window where you can choose your language, theme, and a few other settings. For the navigation style, I'd say just play around with the options and see what feels right for you. If you're coming from Fusion, I suggest trying the Revit style. As for the theme, I stick with the light one to make things easier to see on screen. But if you're a fan of dark mode, go for it. Usually, I kick things off with an empty file, and for this project, that's the way to go. I'd recommend you do the same. Just click on the empty file icon. Before I dive in, I like to have my task panel on the right side of the screen. So I select it, hold down left click, and drag it over to the right. Before we jump headfirst into modeling, I think it's worth taking a sec to explain the method I'm going to use. Since this is a pretty straightforward framework, I'll start by drawing a master sketch that's basically a side view of the carport. From that master sketch, I'll then extrude each piece to get a 3D volume. The master sketch is super key here because it gives us all the dimensions of the different parts and shows how they fit together. It lets us do a direct assembly without messing around with a dedicated workbench and all the headaches that can come with it. Plus, if we need to tweak something later, we can easily do it through the master sketch. So it's crazy important. Alright, so let's get started with that master sketch. To create it, you'll need to head over to the Sketcher workbench using the drop-down menu. If I'm not being clear enough in my explanations, I'll throw in an arrow on the icons I'm clicking. You can also check out the keyboard shortcuts I'm using down in the bottom right corner of the video. And if I'm going too fast, no worries. You can always tweak the playback speed in the video player. To create a sketch, just click on the icon with a square and a red circle in the toolbar. In the pop-up window that comes up, it'll ask you to pick an orientation plane for the sketch. Since we're going for a side view, you can choose either the XZ plane or the YZ plane. Let's go with the XZ plane, then hit OK to confirm. FreeCAD will automatically snap perpendicular to the plane, so we can draw flat, like we're sketching on a piece of paper. Let's start by drawing the slab, which will be the base of our carport. To do that, we'll grab the rectangle tool from the toolbar. Then, draw a rectangle below the red axis, starting by placing the first corner on the green axis. You'll have the option to input values. Set the length to 4,700, hit enter to move to the height, and then set the height to 210. Let's zoom out and pan the view a bit to get a better look at everything. To stop using the tool, you can either right-click or hit the escape key. You can drag the red dimensions around by holding down the click to make things look a bit cleaner and more spaced out. Now let's set a dimension for the gap between the red axis and the slab. Head up to the top menu and pick the Dimensions tool. Then click on the top edge of the slab, followed by the red axis, and set the dimension to 100. The sketch should turn green, which means it's fully constrained and locked in place. You'll see the green lines, or you can check the Tasks menu where it'll say fully constrained. Now let's draw the rear post of the carport. Using the Rectangle tool, draw a rectangle by placing the first corner at the origin of the axis, then enter a width of 200 and a height of 2020. If, like me, you didn't quite snap the corner to the origin, no big deal. You can move the post. Select the bottom right corner, then the red axis, and click the Coincidence Constraint tool. The post should now snap right into the correct position. Now let's draw the front post using the same technique. Create a rectangle on the red axis to the right of the first post, and enter a width of 200 and a height of 2950. Then, using the Dimension tool, set an outer gap of 3,400 between the two posts. We're going to have a bunch of constraints and dimensions on this sketch, so to make it easier to read, I'm going to space out the dimensions a bit, but honestly, that's totally optional. Now let's draw the rear rafter. For this, we'll use the line tool and draw two lines between the two posts, snapping to their edges. Hit Escape or right-click to stop using the tool. Then select both lines and click the Parallel Constraint tool to make them parallel to each other. To set a height for this beam, grab the Dimension tool and select both lines. You might run into a bug like I did. No worries, it's an easy fix. Just double right-click to stop using the tool. Then drag the bottom line vertically and try setting the height to 235 again. That should do the trick. Now we're going to tackle a super important step. To use a single sketch for our entire carport, we need to clearly separate each part in the sketch. Right now, that's not the case. Our rafter is just two edges, and we need to split the sections that touch the posts. Without this, we won't be able to extrude the rafter properly. The method we'll use is the Split Edge tool, which lets us create an intersection point. Basically, it cuts a line into two while keeping most of the constraints intact. You'll find the Split Edge tool in the drop-down menu of the Trim tool. Select the tool, then click twice in the area where the rafter meets the post. This will create 2 points that split the edge. Do the same thing for the front post. Now we're going to make the newly created points coincident with the intersection points. To do this, select a point and the edge, then use the Coincidence tool. The 2 points should merge together. Repeat this process for the 3 remaining points. You can use the C shortcut to make things coincident, which can save you a ton of time. You should now have the inner edge of both posts split into 3 segments, which is exactly what we want for the extrusion step later on. Next up, we're going to draw the cross-section of the big side beams. To do that, we'll use the Centered Rectangle tool, which you can find in the Rectangle drop-down menu. Start by snapping the center of your rectangle to the middle of the top edge of the rear post. Then set the width to 90 and the height to 235. Once that's done, repeat the exact same process for the front post. Again, make sure you snap it to the center of the top edge and give it the same dimensions. The 2 rectangles you just drew should turn green. If they don't, try grabbing one of the corners and moving it slightly to see if it shifts. Now we're going to sketch the side view of the battens, which will help us constrain the rafter. For this, use the Polyline tool and roughly draw the batten shape. Just make sure that both ends are perfectly vertical. You should see a little red vertical indicator next to each segment if it's aligned properly. You'll want to make sure the 2 long edges are perfectly parallel, so select them both, then click the Parallel Constraint tool, or just press P on your keyboard. To avoid the classic dimensioning bug, go ahead and nudge the bottom edge vertically just a bit. Then, using the Dimension tool, set its thickness to 85. Now we need to constrain the batten to the rest of the structure. The left edge of the batten needs to be vertically aligned with the center of the rear post. To do that, we'll use the Line tool to draw a line across the center of the batten. A pop-up message might appear when you click. Don't worry about it, just keep going. Once the line is in place, select it and turn it into a construction line using the button in the toolbar. Now, select the bottom point of the right edge of the batten and the midpoint of the construction line and apply a vertical constraint between them. This will align the 2 points vertically, snapping the batten right into place. Next, select the bottom edge of the batten and the left corner of the rectangle. Then, apply a coincidence constraint to snap the batten right up against the beam. Now, just repeat the same process for the batten on the left side. Select the bottom left edge of the batten and the top left corner of the rectangle, then apply a coincidence constraint to snap them together. To fully constrain it, we just need to give it an offset value on the left, which will set how far it sticks out past the post. So, grab the Dimension tool and set a horizontal distance of 400 between the end of the batten and the post. The batten should now be fully constrained. Now we need to make the rafter and the batten parallel. To do that, select the bottom edge of the batten and the top edge of the rafter, then apply a parallel constraint. Now, using the Dimension tool, we will set a gap of 235 between the batten and the rafter. This will match the height of the lateral beam. The next step is to sketch the section of the lateral beam. To do that, we'll use the Line tool and draw 2 lines. These 2 lines should be parallel to each other and perpendicular to the slope. To make the section perpendicular, select the top edge of the rafter and the section line, Then click the perpendicular constraint tool. Now we need to set the width of the section. Select the dimension tool and enter a value of 90. To fully constrain it, we need to add one more dimension. Using the dimension tool again, set 1500 from the post. Same deal as the post joints. You gotta break up those long lines to make the short ones for the section. Use the split edge tool to create 4 split points. Don't stress if the sketch turns orange. We'll fix it. Just keep moving those points. Head to the Tasks menu, click on the number in parentheses, then hit Delete. Keep repeating this until the sketch is no longer orange. Now you can totally slide those 4 points along the edges, no problem. Like we did before, select a point and then the edge of the section, and apply a coincidence constraint. You can use the C key to speed things up. If you've followed all the steps correctly, the sketch should turn green again. If you're struggling with this sketch, don't forget you can just download it and open it ready to go in FreeCAD. Check out the link in the description. Let's sketch out those 2 braces to make the structure nice and sturdy. Just like we did for the beam side section, we'll use the line tool. Draw 2 parallel lines starting from the post and going to the rafter. Repeat the same process for the front post. Next, we need to make them parallel. Select both lines and click the parallel constraint tool. Do the same for the right brace. You can use the P shortcut to save some time. We'll split the long lines into shorter segments using the split edge tool, just like we did earlier. Create 2 points at each intersection where the brace meets the post and the rafter. I think you know the drill by now. Select the point and then the edge, and apply a coincidence constraint, either by using the tool in the menu or pressing the C key on the keyboard. Do the same for both braces. Once that's done, we need to give the brace a width. Use the dimension tool and set the width to 140 for both braces. Still using the dimension tool, set the height for each brace relative to the red axis. For the left brace, set the height to 1150, and for the right brace, set it to 1700. All that's left is to set the angle for the brace. Give it an angle of 45 degrees relative to the vertical of each post. After this step, the sketch should be completely green, meaning everything is fully constrained. You should also have each piece separated. This is really important for extruding the parts later on. Now, we're going to draw the crossbeam, which will link the back part of the carport to the front part. Using the polyline tool, draw the shape of the crossbeam by snapping to the rafter at the beginning and end of the sketch. Right-click or press Escape to stop using the tool. Then select the bottom line and apply a horizontal constraint. Then use the dimension tool to give the crossbeam a height of 235. Still using the dimension tool, set a vertical distance of 2100 from the bottom edge of the beam to the red axis. The crossbeam should now only be movable horizontally. This horizontal position will be determined by the large side beam. Just like for the other parts, you need to split the segment that touches the rafter. Using the split edge tool, create 2 points at the intersections between the rafter and the crossbeam. Then select the point and the edge and apply a coincidence constraint. Repeat the same operation for the second point. The segment should now be properly separated from the main edge. Make sure you're really selecting the edge and the point. It can be a bit tricky, and I struggled a bit myself because I couldn't select them at first. Now, let's draw the section of the front main beam. Using the polyline tool, draw a vertical line followed by a horizontal one, then a vertical line at the right end of the crossbeam. Make sure the points are coincident with the beam. Then, using the dimension tool, give it a height of 235 and a width of 90. Also, provide a horizontal length of 100 between the edge of the section and the end of the beam. Now, we will draw the side view of the front batten. This will allow us to fully constrain the sketch. To do this, we will use the polyline tool and trace the shape of the front batten, starting and ending at the edge of the rear batten. Make sure to create a vertical line at the end of the batten. You need to make the two long lines parallel using the constraint tool. After that, select the top right corner of the section and the bottom edge of the batten, then apply a coincidence constraint. Next, use the dimension tool to give an offset of 400 from the end of the crossbeam. Finally, to fully constrain the batten, select the top right corner of the highest beam and the bottom edge of the batten, and apply a coincidence constraint. The sketch should now become completely green. We still need to separate the left section of the crossbeam. Again, use the split edge tool to create 2 points inside the section. Then select a point and the vertical edge and apply a coincidence constraint either by using the tool or with the shortcut C. We will now draw the front rafter. Using the polyline tool, we will trace its shape starting from the post, drawing a line to the lower corner of the section, then a new line coincident with the bottom edge of the crossbeam, followed by a line returning to the post. Next, the points of the rafters need to be at the same height. Select the 2 points and apply a horizontal constraint. Repeat this action for the 2 points below as well. Once this is done, you need to make the 2 long lines parallel. Select them and apply a parallel constraint. You also need to separate the rafter segment from the post. To do this, use the split edge tool to create 2 points, then make them coincident with the corresponding points, just like we've done from the beginning. We only have one piece left to draw, and we'll be done with the sketching. Now, we need to draw the last brace. Use the line tool to draw 2 lines starting from the post and extending to the rafter. Apply a parallel constraint between the 2 lines. We will horizontally align the points of the front brace with those of the middle brace by selecting the points on either side and applying a horizontal constraint. This will have the effect of giving them the same width. Next, we will separate the junction between the post and the brace so that it is completely independent using the split edge tool. Create 2 points and then make them coincident with the edges. And finally, to wrap up this beautiful sketch in style, use the dimension tool to set a 45-degree angle for the brace relative to the vertical of the post. I'm happy to announce that we're finally done with this sketch. It was a bit tricky. Congratulations if you've made it this far. You've completed the hardest part. If your sketch isn't perfect, don't worry. You can download the finished version from the link in the description. Before leaving the sketch, take a moment to inspect it and make sure all the segments are properly separated from each other. Otherwise, you'll run into issues during the extrusion steps. I think we can now close the sketch and move on to the next step. Let's start by renaming our sketch using the F2 key and name it master_sketch. This will make it easier to find later if we need to adjust any values. To bring this sketch to life, we'll switch to the part design workbench as it includes many useful tools for this project. So go ahead and use the drop-down menu, then select part design. To be able to create solids in this workbench, you first need to create a body. In our case, each part of the carport will be stored in its own body. To create a body, simply click on the icon that looks like a blue L shape. You should see a new body line appear in the tree view on the left. Now, how do we link the master sketch to our body? For example, if we want to model the back post, if we select the corresponding lines from the master sketch and try to make an extrusion, we get an error message advising us to use a shape binder. To do this, you first need to make sure that the body is properly selected It should be bold and have a green background. Then click on the master sketch, and then click on the shape binder icon. Speaking of the shape binder icon, I've always thought it looks like Ditto, the Pokemon. Let me know in the comments if you think the same. It has always triggered me. Anyway, you should now see a new entry inside the body called Binder. If you hide the master sketch by clicking on the eye icon next to it, you should see yellow lines representing the master sketch projected into the body. We'll be able to use these lines to create our different parts. Let's start with the rear post. Select the yellow lines that make up its outline. Make sure to hold down Control while selecting, and don't miss any lines or you'll get an error message. Then click on the pad icon to create a solid. In the tasks panel on the right, you can set the extrusion length. In our case, we're using 200 by 200 posts, so you need to enter 200. Then click OK or press Enter to confirm the operation. Congratulations, we've just created our first solid. To keep our file organized, let's rename it to post_back by pressing the F2 key on your keyboard. Now we need to repeat this process for every part of the carport. Create a new body, make sure it's selected. It should appear bold and green. Then click on the master sketch and hit the subshape binder icon. We're going to make the front post. Carefully select all the contour lines that make it up. Hold down Ctrl while clicking and make sure you don't miss any. Then click the pad tool, enter a length of 200, and validate. I'm going to rename the body using the F2 key and call it post_front. Now we're going to create the back rafter. We'll repeat the same process as before. First, create a new body. Then bring in the master sketch using the subshape binder tool. Next, hide the two posts to make it easier to select the yellow outlines of the rafter. Hold down Control as you select the edges. Then use the pad tool to create the extrusion. For the rafter, its thickness is 90. So enter 90 in the length field. Then click OK or press Enter to confirm. Using the F2 key, you can rename it to rafter_back. Then make the two posts visible again. As you can see, the rafter is not placed correctly. It should be centered between the two posts. To move it, go to the data properties of the solid, find the placement line, then under position, move it along the y-axis using the calculation. 200 minus 90 divide by 2, which gives 55. Then press Enter. You'll see the part move briefly, but then it snaps back to its original position. That's because of the shape binder. You need to move the binder, not the solid itself. So, select Binder 2 in the tree view, go to its data properties, and change the Y position to 55. You can either type 55 directly or click on FX to enter the operation if you prefer. The rafter should now be properly centered between the two posts. Now let's create the two cross beams. Start by creating a new body, then import the master sketch using the shape binder tool. Next, select all the contour lines. Make sure not to miss any, especially the small one at the end. Then click on the pad tool to perform an extrusion. In the panel on the right, set the extrusion length to 90, then click OK or press Enter to confirm. Just like the rafter, it's not in the right position. To move it, we need to move Binder 3. So, select Binder 3, go to its data properties, and change its position along the y-axis to -35. Feel free to rotate your model to check if it's properly sitting on top of the rafter. Once everything looks good, you can select the front edge and apply a chamfer using the chamfer tool, setting the value to 115. Click OK or press Enter to confirm. Then, using the F2 key, rename the body to cross_beam_right. The left crossbeam is exactly the same, with just a slight Y translation. To create a linked copy, meaning any change to the original body will also affect the copy, you can use the clone tool. It's the icon with an orange sheep, a reference to Dolly, the first cloned animal in history. To create this copy, select the crossbeam right, then click on the orange sheep icon. This will generate a new body in the tree view. identical and positioned at the same location. Rename it using the F2 key to cross_beam_left. To move it, go to its data properties, then in the placement field, set the Y value to 180, which corresponds to 2 times 90, because we need a 90 space between the two beam to add the brace. Feel free to rotate the structure to check if the part is in the right place. It's always a good idea to double check from different angles. As you can see, the two cross beams go straight through the front post. We need to make a cutout in the post to properly fit the cross beams. To do that, we'll use a sub-shape binder. First, double-click on the post front to activate its body. Then, while holding Control, select both cross beams and click on the sub-shape binder icon. This will bring the two beams into the post front body and create a binder. Once that's done, select the post front body and the binder 4 while holding Control. Then click on the Boolean operation icon. In the task panel on the right, at the bottom, choose Cut, then click OK or press Enter to confirm. Now go to the tree view and hide the two crossbeams. You should see that the cut has been applied, and there's now a proper notch in the front post to fit them. I think this is a good time to save your work. Just hit Ctrl+S. Better safe than sorry, right? Now we're going to create the front rafter. Just like for the other parts, start by creating a new body and then add a subshape binder from the master sketch to project it into that body. I recommend hiding the two crossbeams and the front post so you can more easily access the yellow lines. While holding Control, select the yellow lines that define the front rafter, then click on the Pad tool. In the panel on the right, set the length to 90, then click OK or press Enter to confirm. Next, select Binder 5 and in its data properties, set the Y position to 55. You can now unhide the bodies we previously hid to admire your progress. And don't forget to rename the body to Rafter Front by pressing F2. Now let's create the brace that will provide rigidity between the back post and the rafter. Start by creating a new body, then add a subshape binder from the master sketch to project it into the body. Next, hide the back post to make it easier to select the yellow lines. Then select the full contour of the brace. Use the Pad tool to extrude it. In the panel on the right, set the length to 90, then click OK or press Enter. Now select Binder 6 and adjust its Y position to 55 so it sits in the right place. And using the F2 key, rename the body to brace_back. You'll need to repeat this process for the other two braces. Since it's exactly the same steps, I'm going to speed up the video to 3x. If it goes too fast, feel free to slow it down in the player. But I believe that if you've made it this far, this part won't be a problem for you to follow. I'd like to take a moment to thank you for watching the video all the way through. You're making me a very happy caveman. Let me know in the comments what we should model next after this carport. Now we're going to model the slab that our carport will sit on. To do that, first create a new body, then make a sub-shape binder from the master sketch. Before extruding it, since we're building a fully parametric carport, we're going to use a Varset. This will allow us to create variables and make adjustments more easily later on. To create one, just click the Varset icon in the toolbar. In the menu that pops up, give your variable a name. We'll call it length in our case. Press Enter to confirm. Now in the tree view, select the Varset, and in the data properties, set the length value to 6000. At this point, nothing changes visually. That's normal because the variable isn't being used anywhere yet. To keep things organized, I'm going to drag and drop the Varset just below the master sketch in the tree. That way, I'll have all the key elements I might want to tweak, like the main dimensions of the carport, grouped in one place. Now, select the yellow outline of the slab, then use the Pad tool. In the menu on the right, in the length field, click on the little FX icon. That's going to let us enter our variable. In the expression editor, type Varset length, then click OK or just press Enter. You should see the extrusion happen with a length of 6000. If everything looks good, just click OK or press Enter again to finish. I'm going to rename the body to Slab using the F2 key. And for those of you who are extra observant, You might have noticed that I left a small gap between the posts and the slab. That's completely intentional. It's the space for the anchor bolts that will secure the post to the concrete slab. To create them, we'll start by creating a new body. Then I select the bottom face of the post and turn it into a sub-shaped binder so we can access it in the new body. And I'll do the same for the face of the slab. Next, I hide the slab body and the post back body just to make it easier to access the planes. Then I select the projected face of the post and create a new sketch on it. To improve visibility in the viewport, I hide binder 11. Using the external geometry tool, I project 2 edges from the binder. This gives me 2 reference points for sketching. Then I draw a line between the ends of those projected edges to get the center of the face. I switch that line to construction mode using the construction tool, and then I draw a circle centered on it with a diameter of 60. Although, thinking about it, I might have gone a little overboard. That diameter is probably too big for anchor bolts. Feel free to adjust it if you want. I can now exit the sketch by clicking close. Back in the tree view, I make binder 11 visible again since we're going to use it for the extrusion. With sketch 1 selected, I click on the pad tool. In the panel on the right, under type, I choose up to face, and then I select binder 11 as the target face. Once that's done, I just hit OK or press enter to confirm. In the tree view, I press F2 to rename the body to foot_1. We're going to do the exact same thing for the front post space, so I'm speeding up the video by 3x. Feel free to slow it down if you want to see it in real time, but if you manage to model the first foot, this one shouldn't be a problem. We've now finished modeling the main structure. The trick now is to duplicate and move the entire structure to the right, while keeping everything fully parametric. As we saw earlier, we can clone a body using the clone tool. However, FreeCAD doesn't allow you to clone multiple bodies at once. So I'm sharing a little macro I made that lets you clone all the selected bodies in the part design workbench. Select all the bodies except the slab, and then run the macro. It'll create clones of all the selected bodies, and they'll stay parametric. If you change something in the original, the clones will update too. Now, the goal is to move all those cloned bodies to the right, based on the length variable we created earlier. If I select all the clones and go into the data properties, I can set their position in Y for all, but they have to follow the variable of the length minus 200. If I press enter, the thing is, only the first body actually keeps the expression. So if I change the variable later, only the back post moves. And that's not what we want. To fix that, I'm going to reselect all the clones and reset their Y position back to 0. Then I'll create a part. This object works like a container, and I'll use it to group all the cloned bodies. That way, I can apply the position change to the part itself, and all the bodies inside will follow. So I select all the clones again and drag and drop them into the part. Then I rename the part to clones_parts using F2. Now I can go into the data properties and adjust the Y position. By clicking on the little FX button, I can enter Varset length minus 200. And don't forget to type MM at the end, otherwise the operation won't work. You should now see all the clones in the correct position. To make sure everything is working properly, try changing the length value in the Varset to 4000. All the clones should automatically adjust. You can set the value back to 6000 once you've seen that everything works properly. Now we're going to create the long lateral beams that will connect both structures. Let's start by creating a new body. Be careful. If, like me, you had the clones part selected, the body might get created inside it. If that happens, I recommend dragging it out of the part container. Next, I'll delete the binder I accidentally created. Then I'll select the master sketch and bring it into the body using a subshape binder like we did before. Then, in the 3D view, I select the 4 yellow edges of the beams section while holding Ctrl, and I use the pad tool to extrude the shape. I want the extrusion to happen on both sides. So for direction 1, I want it to follow the Varset length plus an offset of 500, so the beam sticks out a bit. I type Varset length plus 500 mm. And for direction 2, I want it to extend 500 as well, so I enter 500 there too. I'm using fixed values here because 500 works well, but of course we could have created a variable for that too. To avoid creating another body inside the clones parts container, I'm going to deselect it by clicking on it. I'll also add a chamfer to the beam. To do that, I'll select the bottom edge on each side, then click on the chamfer tool and give it a chamfer of 115. I confirm the operation by clicking OK or pressing Enter. As you can see, the beam goes straight through both posts, so we need to make room for it to fit in properly. First, I'm going to rename the body to beam_1 using the F2 key. Then I double-click on post back to make it active, select the beam, and use the subshape binder tool to project it into post back. Next, I hold Ctrl and select both post back and binder 15, then click on the Boolean operation tool. In the panel on the right, I choose cut and click OK or press Enter to confirm the operation. If you hide the beam, you should see that both posts have been cut properly. Same goes for the clone. Now we need to repeat the exact same process for the 3 other beams. Since it's literally the same thing, I'm going to speed up the video to 3x, but feel free to slow it down in the player if you want to follow along at normal speed. Now we're going to move on to modeling the rear battens. We'll stick to our usual strategy, start by creating a new body, then project the master sketch using the subshape binder tool. I recommend hiding beam 2 so it's easier to select the contours. Don't forget the small sections in the middle. Then use the pad tool to extrude the shape. In the menu on the right, and enter a value of 75, then click OK, or press Enter to confirm. Next, we need to move the batten all the way to the left edge. To do that, select binder 19 and adjust its position along the y-axis by entering -500. You can rotate the carport to check if it lines up nicely with the end of the beam. Now, in order to create a pattern from it, there's one setting we need to tweak. Select the body and, under the data properties, in the experimental section, set allow compound to true. This will let us have multiple solids in the same body. Next, select pad 15 and click on the linear pattern tool. In the panel on the right, change the direction to base y-axis. We want the battens to follow the length variable, so click the little FX icon to open the expression editor. In the window that pops up, type Varset length plus 1000, which accounts for the two 500 offsets on each side of the carport. Then press Enter to confirm. As you can see, the batten gets pushed out too far. I forgot to account for the thickness of the batten. So let's go back into the FX editor and subtract 75 from the value. Don't forget to add mm at the end, or the expression won't work. The batten should now be nicely aligned with the edge of the beam. Now I'm going to create a variable to control the number of battens. For now, I'll just click OK to confirm the pattern operation. In the tree view, I select the Varset, and in its properties, I right-click to add a new variable. In the window that pops up, I change the variable type from length to property integer, which lets us enter whole numbers, no decimals. I name it number underscore roof underscore battens, then click OK or hit enter to confirm. After that, I change its value to 15. Now I go back to the linear pattern, and on the right side, under the occurrences field, I click the little FX icon. In the expression editor, I type Varset number roof battens and click OK to confirm the expression. Then I just hit OK again to apply the pattern. Now, if I go back to the Varset and adjust the number of battens, the 3D model should automatically update. I'm going to rename the body using F2 and call it Roof Battens Back. Now let's move on to the front battens. It's the exact same process as the back battens, just like we did with the beams, so I'm speeding up the video here. Think of it as a bit of homework. Feel free to slow it down if you need to, but honestly, if you followed the previous steps, you shouldn't need to watch this part in detail. Now to wrap up the roof, we're going to add some large OSB panels. We'll stick to our usual workflow. Start by creating a new body, then select the top face of the rear battens and use the subshape binder tool to project that face into the new body. Next, hide the roof battens back body to keep things clear. Select binder 21 and create a sketch on top of it. Using the external geometry projection tool, click on the bottom edge of the binder. Then grab the rectangle tool and draw a rectangle starting from the lower right corner of the binder. Make sure the shape is larger than the whole carport. Now select the lower left corner of your rectangle and make it coincident with the bottom left corner of the binder using the coincidence constraint. Then, using the dimension tool, set a vertical dimension for the rectangle. Click on the FX icon and enter Varset length plus 1000. This way, the OSB panel's length will adjust automatically with the carport. Once that's done, you can close the sketch by hitting close. You can now hide the binder and make the roof batten's back body visible again. Next, select Sketch 3 and click on the Pad tool. In the right-hand menu, set the length to 18 mm, which is a standard OSB thickness. Then click OK or press Enter to confirm the operation. Using the F2 key, rename the body to OSB Back. Now we're going to do the exact same thing for the front OSB board. Since the process is identical, I'll speed up the video. The carport model is now complete. My goal with this tutorial was to show you how you can model a more complex object parametrically in FreeCAD and even build an assembly directly without using the assembly workbench at all. Everything is fully parametric, so you can go back to the master sketch, adjust the values, and the 3D model will update accordingly. As a bonus, I've created a macro that generates a parts list for the carport. It works for any project made with the part design workbench. The macro creates a spreadsheet with all the bodies in the file. It groups together bodies that have the same volume, giving you a quantity count for each. And if a body contains multiple solids, like the battens, it'll count the total number of solids. I also added a dimensions column based on the bounding box of each part. This can be super helpful if you're making cutting lists. Just keep in mind the values will only be correct if the object is lying flat. If the part is rotated, the dimensions might be off. You can download the macro from the link in the description. Let me know what you thought of this tutorial. I hope you learned something, or at least had a good time watching. Thanks for your attention.